In the vast cosmos, stars are often seen as symbols of permanence and stability. Yet, scientists were recently stunned when a star appeared to vanish without warning. Telescopes around the world had been observing the star, located in a distant galaxy approximately 75 million light-years away. Overnight, it simply disappeared from view. This unexpected vanishing act defied conventional astrophysical theories. Normally, stars end their lives in dramatic explosions known as supernovae. These bright, energetic events are visible for weeks or even months. But this star showed no such explosive finale. Instead, it appeared to fade quietly and completely, leaving behind no visible trace. Astronomers have dubbed it a failed supernova, a theoretical but rarely observed phenomenon. In a failed supernova, a massive star collapses directly into a black hole. This collapse happens so rapidly and with so little outward energy that no explosion occurs. Instead of going out with a bang, the star simply ceases to emit light. If confirmed, this would be one of the first direct observations of such an event. Researchers used data from the Hubble Space Telescope and the Very Large Telescope in Chile to study the star. The star was a massive red supergiant, estimated to be around 25 times the mass of the Sun. Before disappearing, it showed signs of instability, including irregular brightness and spectral changes. These fluctuations hinted at internal chaos, possibly linked to core collapse. Scientists expected a bright supernova to follow. Instead, all light from the star stopped, as though it had blinked out of existence. Follow-up observations confirmed the absence of any lingering supernova remnant. No expanding cloud of debris, no glowing nebula, nothing. This deepened the mystery and excited the scientific community. One possibility is that the star underwent a direct collapse into a black hole. The core collapsed under its own gravity, forming a singularity without releasing outward shockwaves. This silent death is theorized to occur in stars above a certain mass threshold. Until now, it remained largely speculative. Another theory involves extreme dust obscuration. It's possible the star's light is being blocked by a massive dust cloud. However, infrared observations showed no increase in dust-related emissions. This reduces the likelihood that dust alone caused the disappearance. Scientists are also investigating whether the star experienced a massive outburst that expelled its outer layers. If so, the remaining core could be too faint to detect. Alternatively, the star could have collapsed into a neutron star instead of a black hole. Yet this too would typically involve a visible supernova. The vanishing star poses a challenge to current models of stellar evolution. It suggests there may be quiet pathways to stellar death we do not yet fully understand. Understanding these events is critical to refining our models of black hole formation. Black holes are born from the deaths of massive stars, but the exact mechanisms are still under study. Direct collapse offers a new avenue for understanding how stellar mass influences black hole birth. The implications of this observation extend beyond one star. If failed supernovae are more common than thought, we may be underestimating black hole populations. This could impact theories about galaxy evolution, since black holes play a crucial role in regulating star formation. Astronomers are now reviewing archival data to search for similar cases. The goal is to identify other stars that disappeared without a visible supernova. New sky survey technologies, such as the Vera C. Rubin Observatory, will make it easier to track stellar behavior in real time. These systems can detect subtle changes in brightness across billions of stars. The disappearing star may also inform gravitational wave research. A silent collapse into a black hole could still produce gravitational waves. In the future, gravitational wave detectors might catch such events even when no light is visible. This would open a new window into black hole formation and stellar death. The event has sparked interest in multi-messenger astronomy. This approach combines electromagnetic, gravitational, and neutrino observations. Together, they provide a fuller picture of cosmic phenomena. Some researchers speculate that neutrino bursts could accompany failed supernovae. Neutrino detectors like Super Kamiokande in Japan could play a role in confirming such events. The scientific community remains cautious but intrigued. More data is needed to confirm the cause of the star's disappearance. If confirmed as a failed supernova, it would be a milestone in astrophysics. It would validate long-held theories and inspire new research into stellar death mechanisms. For now, the star remains invisible, a ghost of what once was. Its silence speaks volumes about the power and mystery of the universe. As astronomers continue to monitor the region, they hope to detect faint afterglow or gravitational signals. Until then, the mystery of the disappearing star remains unsolved. It is a cosmic reminder that even the most familiar celestial bodies can still surprise us. And that in the universe, not all endings come with a bang. Sometimes, the greatest transformations occur in silence.